Okay, so what we're going to do here is very similar to what we did before with the absolute value. You remember we graphed the absolute value and we said it's equal to some number. That was the horizontal line. And then we could see where they intersect, and okay, those are the two answers graphically. So, and then we went ahead and solved it using an equation. So just remember an intersection on a graph, like where two things intersect. That's the same thing as an equal sign when you're solving. So if you're trying to find out, well, where is it equal, that means intersection. So if we graph both of these and see where they intersect, that's going to be the same solution as this equation right here. Now, you're going to find out that the graphing of these is not quite as easy because one's curved, one's straight. But we're going to go through one of them just to see what they look like. So the first one, you can see we only have positive x's here. So this starts at 0 and goes to the right. So when I'm using x's here, I can't use any negatives because that would be over here, and we don't have that part of the graph. So let's just start at 0, right? Count up a little bit. And do the same for here. All right. And graph them both and see where they intersect. Now you'll be able to see the answer before we even graph it because it's basically, well, when do we have the same number on each table? So let's plug these in. 3 to the 0 power is 1. All right. 3 to the 1 power, 3. 3 to the second, and 3 to the third, 27. 3 to the fourth, 81. Okay, and let's stop there just for a second and do the other one. Okay, now there is no actual x in here, so you can think of this as just 0x plus 27, right? So if you plug in 0, what do you get as your answer? 27. Plug in 1, what do you get as your answer? 27. Plug in 2, what do you get? 27. Yeah, remember, it's just a horizontal line. So you plug in 0 times 1 is 0, plus 27 is 27. 0 times 2 is 0. 0 plus 27 is 27. 0 times 3 is 0. 0 plus 27 is 27. So it doesn't matter what x value we plug in here. We get an answer of 27 no matter what. Okay? So let's go ahead and graph it, see what it looks like. Now I stopped here because I didn't want to go too high because that makes it difficult to graph. So we don't need to go quite that big. And we can already see the answer. It's where they're the same. So you can see how they both have a 3, 27. So where they're the same on the table, that's where they intersect on the graph. So we already know what the answer is going to be to this equation. X will equal wherever they're the same, right? X will equal 3. So let's graph it and see what it looks like. And I'm going to graph it up to 4, so I'm going to space this out a little bit. 1, 2, 3, 4. Go every fourth square. 1, 2, 3, 4. I'm trying to create space so it's a little bit easier to see the answer. 1. There we go. And I need to graph up to 27. And since these are all multiples of 3 on the y, you look at both columns, they're multiples of 3. That's a good indication that when you're labeling your axes, you should probably count by 3s. So let's count by 3s. Let's start at 3, 6, 9, and 12, and just count up by 3s. And since I already know, I keep going. And you can see why I kind of stopped. I don't really need to go up to 81. We already know they're going to intersect at 327, so as long as we have the intersection plotted, that's the main point. Alright, so we got both of these. Let's plot them. So 0, 1, right down here. 1, 3, right there. 2, 9, here. 3, 27, here. And 4 comma 81, if we kept on going, we're only at 40, so 81 would be like way up here, something, you know, twice as tall. And if you tried to graph it, nice smooth curved line. And then if you graph y equals 27, that's just a nice, well, not so horizontal. Should be a nice horizontal line to 27. And as expected, we can see our answer graphically, just like we saw in our table, at an x value of 3. So we see on the table our answer is 3. We can see on the graph by the intersection that our x equals 3 where they intersect. Okay. So the question is, how do you do that on an equation without a graph, without a table? How can you do this without doing all this extra work? Okay. So what you're going to do is ask yourself, if you have two different bases, ask yourself if they're the same base, what would the right value of x be? So 27 is 3 to what power? Okay. Right? And you can say, well, yeah, 3, right? 3 to the third power is 27. We already knew the answer was 3. And that's how you're going to figure that out, that if you have both bases the same, their exponents are also equal to each other. So the goal is to get the bases equal to each other and find out the exponents. Okay? Now, on your homework, just like this one, I don't really want to spend time doing the graph so much, just solving algebraically. So we're not going to do the graphing in the table for these ones. And same thing on your homework. Just do the graphing in the table for the first one only. But everything else, just solve algebraically, because it's not too effective because of things like this, how the numbers get so big so quick. It's not really effective to solve by graphing. Table still works okay, but not so much the graphing. So just ask yourselves, okay, so 16, can we write 16 as a power of 4? So 4 to what power is 16? You say 2. Yeah. 4 to the second power is 16. So therefore, if the bases are equal, the exponents are equals as well. So x equals 2. So if we went through all this, and you think about, what is it asking? Yeah, 4 to what power equals 16? Oh yeah, 4 to the second power is 16. Right? That's not too big of a jump, right? Question? We're getting there. Okay. So on these, you can see we have something with a coefficient in front. So treat this like you would here. Okay. If you had a coefficient in front, this means multiplication, you would just go ahead and divide by it, right? Divide by the coefficient. Same thing here. So if we have this coefficient of 8, and be careful that 8 is a coefficient, 2 is a base. So you might be thinking, oh, they're both, quote, big numbers, but 2 is not a coefficient. 2 is a base. So you always divide by a coefficient, a number that's being multiplied by. So we can cancel those out just like we always do. Same rules we're used to doing. And then figure out, okay, 4 is 2 to what power? Right. 4 is 2 to the 2. So therefore, bases are equal, exponents are equal, x equals 2. So we're using a lot of the same properties we've always used to undo things. Okay, and let's hit up the back, and you can see it's all solving on the back, and that's the focus of the homework, is the solving algebraically. So let's do a few of those just to get used to it. And at some point you get the hang of it and you kind of know how to do it. Just go ahead and start solving them on your own, and just check, look up, and see if you get the same answers. Okay, so 5 to the x. 625. By the way, all the numbers you're given are nice, easy numbers. So you just have to do maybe a little bit of work on it, but they won't come out to like, decimals or something like that. So you just have to figure out, like, okay, how many times do you have to multiply 5 to get 625. So a calculator might be handy, but if not, you can just say, well, 5 times 5 is 25. 25 times 5 is 125, and 125 times 5 is, that's the 625. So you can count up. We multiplied 1, 2, 3, 4. 4 5s, we got 625. So 625 is 5 to the 4th. Right? Bases are equal, so are the exponents, so x equals 4. So calculator is handy, but not absolutely required. You can still do all this without a calculator. Okay, you might just have to do a little arithmetic on the side. Okay. Number 2, we have a coefficient of 3, so let's divide both sides by 3 first. So 2 to what power equals 8? All right, and yeah, 8 is 2 to the 3rd power, so x equals 3. Okay. Let's see here. So let's go down and do them all so you have plenty of examples for your notes. Again, at any point if you think you got the hang of it, just go right ahead and do them on your own. Just check up, make sure your answers are right. So we have a coefficient of 6 on number 3. So 3 to the x. 3 to what power equals 9? 9 is the same as 3 as to the 2nd power, therefore x equals 2. You can see here we have like a plus 10 away from the base, so same thing you've always done to get rid of a positive 10, and subtract 10. So, a lot of familiar steps, just that last step is new. So 131 minus 10 is 121, and now you just have to figure out 11 to what power equals 121. And you might know this number or not, depending, but it will be a nice number, I promise. So, yeah, 11 times 11 is 121. Therefore, x equals 2. Let's see, add 56 here. We have 6 to what power equals 216. That might be one of those you have to go off to the side, say, okay, 6 times 6 is 36. Multiply 36 times 6 and you get 216. Right, so that would be 6 to the 3rd. 6 to what power? That's 6 to the 3rd, so therefore x equals 3. You are allowed to use a calculator on any test, quiz, final. Okay, so have one handy, as I mentioned before. You just can't use the phone at all during a test, quiz, or final. Okay, so don't rely on the phone, and then once it's time for the points that really count, you can't use it, and you're not used to working without it. Number 6, very similar to what we've always done, so just pretend if this was a 5x plus 2 equals 322, how would you solve that? Right? You would subtract 2 on both sides, and then you would divide both sides by 5. So same thing here, start off by subtracting 2 on both sides. And you can see why we use the parentheses here, so it's a little bit easier to see what's coefficient and what's a base. Divide both sides by 5. So what's 320 divided by 5? 64, okay. And then we just have to figure out 64 is 4 to what power? Yeah, 4 times 4 is 16. 16 times 4 is 64. So we have, takes 3 4s. So 4 to the third. X equals 3. Okay. So looking at both of these, first step on number 7 would be to get rid of positive 5 by subtracting 5. Second step, we can get rid of multiplying by a half by multiplying by its reciprocal. So multiply by 2 or 2 over 1. On number 8, we have a minus 7, so we need to add 7 to both sides. And then we have a times negative 3, so divide both sides by negative 3. So you want to have that, just like you always have that plan ahead of time. Don't just start the problem and not really know where it's heading. Divide both sides by 2. We have 2 to what power equals 128? So you have to figure that out. 2 to what power equals 128? I'll let you come up with those. Divide by 3 everywhere. So 5 to what power equals 3 divided by, 375 divided by 3 is positive 125. So 5 to what power equals 125. So that one's a little bit easier. We did it earlier for number 1, I believe. So yeah, 5 to the third power equals 125. X equals 3. The 128, that might take a while. 2 times 2 is 4, times 2 is 8, times 2 is 16, and just keep on going until you get to 128. I think it comes out to 7, is that right? So X equals 7. Alright, so there's plenty of examples, plenty of notes for your homework, and you can pick your homework up on the way out.